not. So again, good evening, everyone. So my name is Go. I'm gonna talk about something about Emoto. So first of all, what is Emoto? Emoto is a music player with emotional AI. So first of all, let me just a little bit about myself. I have a hobby to play the music, and I play the drums quite a long time. And I always feeling to get something like emotion. For example, like when I play the happy songs, you're feeling the happy, right? But also, like, even though I play the songs and kind of sad, but I always getting some like a comfortable feeling. You know why? Because my emotion and music is matching. I believe you're also having like a same experience. For example, you are in the kids, for example, imagine that, and band playing the happy songs. What do you feel? It's kind of exciting, right? It's kind of that. But also when they play the sad songs, you're just like standing and then kind of like crying, but still feeling comfortable because the music and your emotion is matching. So we give this experience directly and live to you. For example, when you're feeling the happy, we choose the happy songs for you and then play and with great visualization. Even you're feeling the neutral, we give some like meditation song to be relaxed for you. Even you feel something like a sad, but still we can give the sad songs and release your emotion to be more refreshed. Let me go to the demo to show you more detail. This is our first landing page, so music for every emotion. This is our concept. And we, as I said, we have the nice visualization, so not only listen to music, but also enjoy the visualization as well. We have the nice voice command and function that I show you in the demo. And also this recognition is working the AI facial analysis. So let me go to the main page. Oh, first of all, this is connected to the Spotify. So once you haven't logged in yet, it brings you the login page. And after you click the login, it brings you to the main page of our Emoto. And in the beginning, it starts to play the songs with your top song of the Spotify. It's landing. And then, yeah, the nice visualization is working. Oh, let me stop first. Okay, so let me start to explain what is this working. Yeah. In the center see here, this one, is a camera, the webcam, right? And then it detects your image every 10 seconds. Every 10 seconds. And then you like a face image like this. And then also it brings to the AI side, and then AI recognizes your emotion based on the image. And then it passes to the this value. So now it shows the 0.5, which is neutral. Okay? And it close to the 0, and it means you're sad. It close to the 1, it means you're happy. For example, then maybe I show you some example. Oh, I'm sorry so much. Okay. So I'm smiling in the face like this. Just like it changes in one, right? And then if I try to make the sound like this, wait, it's coming the sound, yeah. Oh, amazing. Okay, so based on the emotion, based on the image, face image, AI recognizes the emotion and then pass to the our app Emoto, and then it changes the color itself, right? So. And also, again, as I said, we have the visualization. It's not only one. We have 6 nice visualization. Like, see, it's waving, right? It's really nice. And also, sorry, I'm sorry. It's also sparking in front of see, right? And also, like, this is the bar from bottom to the up. And then finally, this is very amazing. You know, this is 3D. It's working for you. So again, not only listening to music, but also visualization. You can enjoy this player. And as I said, we also have a nice function which is voice command. So let me show you one. Great. If I say friend, it's playing for you. Okay? If you no confidence to the accent like me, we also have a Japanese version. We can say like a Teishi or Saisei. It's fine, of course. I'm a Japanese, so that's why I provided that. Also, we have the Easter egg of the voice command. So just come to me, I give you some hint of the Easter egg if you want to know, right? Okay, and as you see in the left side, this is a playlist here. So you see what kind of songs you already played, and also, yeah, there's a player here. And the last part, the choosing the songs. So after this song is finished, and then we give you another song. It comes from here. This one. So this next song comes from the Spotify recommendation. So Spotify, which is your experience? Like you listening a song to the Spotify, right? And then Spotify understands what kind of songs, what taste you like, and they provided a list of the songs. And then we choose the one best songs depending on your emotion. So now it shows the 0.5. That's why we choose the one song from the recommendation list. And then we pass you. So it is more specified. You can enjoy the emotion, the music. So that's all of the demo, and I pass the data to explain what we built this app.
So thank you, Go, for the amazing demo. I hope you all enjoyed. So for the next section, I will take you through the Agile process that we took in order to build our app. So it's going to be a little bit of story time. Initially, for our MVP, we wanted to keep it as simple as possible, having only the core functionalities of the app, which is the login experience, facial recognition, and music player. We intentionally built it as quickly as possible using technologies that we were already familiar with, so that in the next iteration, we were able to brainstorm fully on additional features we wanted to add to enhance the user experience. And all the features that we ended up adding were everything that you were able to see in Go's demo. And we're very, very proud of what we were able to accomplish. And after building all these features, we then thought more about how can we make the app have a better architecture so that we can enhance the performance and scalability and all that. So long story short, we made a huge change to our code in terms of database and server. And even though this was a huge risk that we took, considering the short amount of time that we had to build this app, it was all worth it in the end, because this was the main reason why we were able to learn so much from this experience. So just to give you a little bit of context, I will take you through the thought process behind each decision that we made. So for our database, initially we were using MongoDB, which worked perfectly fine. But because we're storing user-specific data, like their favorite music, for example, we're having the users make unnecessary server calls every time they refresh their page. And even for us developers, we didn't find any benefit in storing this kind of data. And also, we were storing user credentials for login experience. And because this is considered bad practice, we wanted to fix it. And we did by switching to IndexedDB, which is a client-side storage. And for our server, again, we were using technologies that we were familiar with, and it was working. But once we removed our database, we realized that all our code is doing is routing API requests. This isn't necessarily a bad thing, but if we want to keep our app more lean and scalable at the same time, we realized that we can make this possible by going completely serverless. So we switched to AWS Lambda functions, and it worked. So to summarize, by continuously adapting and improving, we learned that not only were we able to expand our skill sets as developers, but also make our app significantly better in a short amount of time. So on that note, I would like to pass it to Wilson, who will talk a little bit more about our tech.
Thank you, Rina. And so this is a quick summary of the architecture that we ended up with. And so this kind of stack is described as kind of thick clients and thin serverless backends. And so let's talk about the serverless side first. And so when we talk about kind of a microservice architecture, we really think about each individual kind of process as a separate service. For example, authentication is a service that we replace with a number of AWS Lambda functions. And because we built it in such a way that it is a microservice, we can actually go and replace that very easily now. And all of these different parts, a third-party API, for example, a AWS Lambda function, we can kind of plug and play with all these different options if we wanted to. So on the front end, because we removed the database, because we have to move a lot of logic to the front end, that's kind of where the thick client comes in, and we use React to build that. As we had described, we also push the database actually to the client side and use something called IndexedDB, which is available in most modern browsers, and use Dex.js, which is an ORM to allow us to access that. And so by doing that, we almost create a full stack app on the client side. For the voice recognition, as you saw Go demonstrate earlier, we use something called WebKit Voice, and that's the API, again, also available on most modern browsers. For the visualization elements that you saw as well, we use 3 different libraries. 3JS, which is a WebGL-based 3D library, Anime.js, which is used for SVG and CSS animations, and we use directly the HTML5 Canvas API in order to do more 2D animations. And so one of the really important parts of this app is, of course, the Spotify API, and that was one of the cornerstones of kind of what we worked with. And there's a lot of amazing things with the Spotify API. So for example, we were able to do authentication and authorization through the Spotify API using their kind of OAuth interface. And so that not only allowed us to kind of recognize who this person was, but also allowed us to play the music associated with their account. The web playback API was also very unique. And so Spotify, as you well know, you have a lot of copyright issues with this type of music. And so the web playback API doesn't actually give us, for example, an MP3 to play, but it instead gives us this DRM stream protected kind of player that we can use to stream music directly into your browser. And that kind of becomes very important in how we do visualization, because it's very common to use the web audio API to do that, but we didn't have access because of DRM issues. So instead of that, Spotify has an API called audio analysis. And audio analysis gives us this 40,000 line JSON file that analyzes every song and tells us exactly when every beat is, how loud it is, all the different sections of a song, and all this data that we use to create the visualization for you. We also use the Audio Features API, which is also another type of analysis that Spotify allows us to use that gives us different information like rhythm and valence and energy and key. And we devised our own algorithm in order to analyze that and basically compare that to whether or not we think the song is sad or happy. And we created that. We use this information to create the matching algorithm that we use to match it up with the song. Lastly, of course, we use Spotify's recommendations API in order to get recommendations based on your own preferences. So how does this app really work, and how does kind of all this come together? So one of the main threads of this app is that this idea that this player is playing all the time, and that because it's actually an API that's giving us this player, it has to constantly pull the API to tell us where we are in the song, and we do that every 100 milliseconds. And so this is a continuous process that keeps updating the state of the application, and it's with that information that we can show you everything that's happening on the browser. Based on that position in the song that it gives us, we also use that to drive the visualizations, and that's why you see that it's synced up. So we know that, if you're in this beat at this point in time, we have to render this visualization for you and animate. And it gets a lot more complicated than that still. So the voice API is also always on, so it's always listening to you to see if you have a voice command for it, and that's always happening in the background as well. And the face API pulls every 10 seconds, mainly based on kind of limitations around the Azure Face API. And we use that to pull for your face and give you that emotional analysis every 10 seconds. And so when we work with this continuously changing state all the time on the client side, we run into a lot of performance issues. And it's always very challenging to deal with all of these different actions kind of populating your call stack in the event loop. And I'll pass it off to Matt to talk a bit more about that.
So for some of our technical challenges, so performance. Initially, we're rendering with SVG and CSS animations and using their accompanying libraries. And this is kind of troublesome because we're rendering typically between 100 to 500 SVG objects in a DOM. And all of these are trying to run simultaneously and continuously every 400 milliseconds, which is roughly the average duration of a beat. And so in order to kind of make it more performant, what we're doing is dropping down to a lower level. And now instead we're drawing out every animation frame by frame using Canvas, WebGL, and 3GS. And the way we do this is that the average beat is roughly 400 milliseconds. The engine is rendering around 60 frames per second. And this comes out to about 25 frames per beat. So we take those 25 beats and using a sine curve, we kind of map these out to each point. And this actually is kind of a bit of a trade-off. And what it does is it allows us to better control the animation and better sync it up with the song at any point in time. And now we have a lot of kind of changing variables that are constantly moving, constantly changing. And anybody that has worked with React before will kind of know that re-rendering can be a bit of a problem. So we have all of these constantly changing components and the variables within. So what we did is we took a deep dive into these using the React Developer Tools profiler. And this kind of gives you a snapshot to see what's rendering when, how often, and when it is re-rendering. So we kind of use some lifecycle methods, should component update for our class-based components, use ref instead of use state in order to provide a mutable variable that when it changes, it doesn't trigger the re-render every time. And through these challenges, we kind of learned a lot. We're able to dive deeper into the technologies and bring to you this great user experience in our app Emoto. So thank you very much. If you're interested in trying out our app, it is live. It's available on emoto.live. Thank you.